Switches, switches, switches. There are thousands, even millions of them, different kinds out there, and you have seen me using them in different products, so on. But today I will talk about this little thing. This is the mechanical limit switches. So you have seen me using this in the hydraulic system, and I'm still using them actually. And the hydraulic system is still on the freaking floor. And the reason is because of these. I can't really blame everything on this sensor. I still have some issues with the hydraulic system. It's not really a problem, but it's creating problems when designing this system. You see, hydraulic systems or hydraulic pump like this has a lag time, and that is between when the motor or the pump motor turning off, you still have some pressure in the valves, which causes the hydraulic piston moving slightly, even though when the pump is off. Push this, so it will move a couple of centimeters, and that is causing some issues for me when I'm designing the system. And also those things creating some problems because they have also the same lag time issue, and those together ended up smashing these switches, a couple of them. So I think I've broken like 6 of them now, 6 or 7. Anyway, I need to find a solution to not smashing these anymore and avoid that lag time on the hydraulic system. Okay, so I will not bother of doing anything on the hydraulic delay thing. It's too many valves that need to be changed out, so I will not do anything on that. I will focus on the sensor side with those limit switches. You can solve this problem in many ways. One way is do it the digital way. You can put a computer and put a time delay on that sensor, or do it mechanically, which I will do. So I will use those limit switches and rebuild them, so I create a little bit of time delay on that sensor. So how I will do it? Let's do this again. So we have the body over here. So this is the stainless steel body for the sensor. So it will be mounted on the inside of this one, like that. And on top of that, we have the sliding bearing. So this piston will run back and forth in this one. I'll take that out for now. But imagine this sensor is mounted in here, and on this bearing we have a small plate, imaginary plate for the moment. So when the piston is coming in, it will hit this, it will go in like that, and this plate will activate the sensor that is sitting right here. But this spring over here, it will belong on the real thing, will create some lag time, so the piston can continue going a couple of centimeters even though the sensor is activated. So hopefully this spring will create enough time to stop the piston before it's smashing the sensor. That's the plan. I haven't really tried this one yet. So let's put it together and see if it works. All right, so this is the sliding plate where the engine is resting on. So the nozzle will be pointed that way. And this is actually the plate that controls the sliding movement and controlling the hydraulic piston and so on. So we had 2 sensors over here on the outside of this unit. And these are basically kill switches. So if they are triggered, it will kill the entire test. So we need to reset them in order to reset the test. So those are just the safety precautions. And these 2 are the 2 sensors that are actually controlling the hydraulic unit and the piston. So when the engine is moving back and forth like this, it will trigger one sensor, and that will stop the movement that way and wait until the time is going back and going the other way. So it will continue doing that back and forth. So that's the purpose of those sensors. I need to activate the system manually, so I will do that with this cable. It will start going in and outwards when I connect this one, so I will trigger the sensor when it's going the right way. So in 3, 2, 1, hip it. It stops going out. It stops going out. Same thing over here. It stops going in. So it works. The only issue I having for the moment is the cables. If we take a look at them. They are heating up pretty fast. Alright, so I lower the light so you can see what's going on around here. So you can see the lamps on the solenoids and everything around it, so when it's working. So I will activate the system. This is just a manual activation of the hydraulic. Safety, you know. So I've disconnected the hydraulic pump or the motor from the pump. So because we don't really have any piston connected to it, so I don't want to run the pump system, but I will run the solenoids. I also connected the hydraulic unit up to a slide plate. That is just to have the motor resting on it and controlling the piston, so it can turn off the system if the engine going rogue, and that will stop the hydraulic piston working. So on that we have a kill switch, a little blue thing over there. I will show you that. But everything is connected to the computer, so we have it over here. But I also connected it to the manual remote. And we have two buttons over here. We have a gimbal start. We can activate the system from this remote. And we also have a small button next to that that says reset, gimbal reset. So I can activate it by pushing that button. You can see it start running. And I mentioned we have a kill switch on that slide plate. So I will activate that. In 3, 2, 1. It kills the hydraulic pump. You have two choices over here. You can either restart, just push this button down and restart the entire system, but I won't do that. So that's where the reset button is coming in. So if we push that, you can see we restarted the computer on the slide plate. That's box over there, and it will start run the hydraulic system again. Or if we turn it off, see it stops. Activate the hydraulics again. Push the kill switch. It stops running. Put that button. We'll start running again. So it works. Turn it off.